Okay, what's up, everybody? Good afternoon. We are gonna be doing our third video on this series on learning how to use Golang. And in this case here, we're gonna be learning how to add a test to Golang. In the last series, we covered a couple of things from how to return greetings for a single person, how to return greetings for multiple people. We also did a little bit into logs and being able to return errors on the terminal. So in this case here, we're going to be adding a test in order to pretty much go through the functions that we've created and make sure that they are functioning properly. Testing is it's an omni thing, right? It's something that you do when you're writing every single production code. You don't do it just because it's necessary. You do it because you do not want the risk behind not testing your code to fall upon the users of your projects or your products. So in this case, we're going to be learning how to write a test in Golang. I'm super excited for this. Um, from the documentation here, it says that Go has built-in support for unit testing, which makes it easier to test as you go, specifically using naming conventions. Go's testing package and Go test command, you can quickly write and execute tests, right? So this is quite great for us because we do not need to have any new installation or any new package or module added into our project. We don't have to run a Go mod in it, which means right off the bat, if we were writing this code without internet access, we would be able to run our test, provided that obviously we're not making any internet calls to a package online or whatever. So in this case here, it says that in greetings, we need to say ending a file. Okay, create a file called greetings test go, right? Obviously, I'm gonna just do things a little different. I'm gonna call mine greet test.go, right? And then it says here that in every file that ends with underscore test.go tells Go test command that this file contains test functions, right? So I guess just adding that makes Go knows that, okay, hey, this is a test file. And it says that we need to paste the following code and save the file. Obviously, we're not going to do that. We're going to try and study the code to understand how it works, and then we're going to read the description of how it works, and then we're going to implement that into our code. So first off here, the thing I noticed is that we are using the same package, right, that we had for the greetings, right? So in the previous code, it was package greetings. I made mine package greet, so that was the difference between mine. And then we are importing two modules, right? We are importing the testing module and we are importing the regular expression module. And then what we are doing is that we are creating a function called test hello name, right? So test hello name calls greetings.hello with a name, checking for a valid return value, right? So in this case here, I can see that we're also passing in a parameter called t, which is of type testing.t, which is interesting. And this is also the first time in everything that we've been doing that I've seen an asterisk put before the type of the test, right? I do not know what that does. I hope that there's an explanation for that at the bottom. Then we have function test hello name. We create a name. Then we want to do a regular expression dot must compile, right? We're going to figure out what must compile means, and then we have this interesting looking expression here, which is saying slash b plus name plus slash b, and then we want to say we want to do this. We want to say message and then error. Obviously we have to pass error because the hello function takes in error too. We want to say message error is equals to hello and then Gladys, right? And then we want to say if not want dot match string message, right, or error is not equals to nil, then we want to return something called t dot error, which I believe it's the testing here, right? So we have a t dot error f hello, then with the text Gladys is equals to, then we have some other expressions here, which is interesting. We have QV want match for Q new message error want. Okay, this is quite an interesting one now because I don't know what's happening here. And then we have another function called test hello empty, which calls hello with an empty string, right? And it says here if message is not empty and error is new, then T error hello, and then we have Q and V again. I want to know what that represents in a sense, right? I want to know. I feel like we need to understand what these expressions mean, right? It will become way easier for us to sort of figure out everything. But let's see. In this code, you implement a test function in the same package, okay, we got that correct. And then you create two test functions to test the greeting, the hello function. Test function names have the form test name, where name says something about the specific test. Also, test function takes a pointer to the testing packages testing.t type as a parameter. You use this parameter method for reporting and logging your from your test. Okay, let's see pointers in Go. Right, let's see pointers in Go and what this means. Pointers in Go store the memory address of a value rather than the value itself, right? Core operators. Okay, I know this is AI now, but well, let's not use AI, right? Let's stick to what we agreed upon, right? Let's stick to what we agreed upon, and let's open what pointers are in our project here. So it says this: Go has pointers. A pointer holds the memory address of a value. The type asterisk t is a pointer to a t value. Its zero value is nil. So VARP is a pointer is a type of pointer to a value integer, right? The AND operator generates a pointer to its operand, right? Okay, which is interesting. So if we print here fmt print line asterisk p, it is going to read I through the pointer p. Okay. So I what happened here is that we created a variable called p, which is a pointer of type integer, right? And then we said I is a value here, and the value that we gave I here is what, 42. And then we go below here and then we define the actual value now that's been allocated to p, and then we are using the AND operator here, which is then creating a pointer to what I is, right? And I think this still follows this because we know that this is going to be of a type integer, right? But we're not specifying the integer here. What we are doing is just pointing it to another value. We are pointing it to I here, which is why this makes sense. This is why this works. Interesting. This is also called different dereferencing or indirecting, right? So let's see the referencing. I don't know if I pronounced that correct in Go or spelled that correct, right? So how does pointer dereferencing work in Go? And we're going to look at some people in Stack Overflow because I didn't see that directly on the Go docs. And we say, I'm going through an example here and I was experimenting a bit. So we have a struct. Yeah, I think this is outside of our level. T is equals to a pointer of Q makes a copy of the struct pointed to by Q. If you want to observe changes to Q through T, then stick with a pointer. Okay. We got that correctly then. We got that correct. So then we are using this parameter method for reporting and logging from our test, right? So this is what allows us to pretty much do reporting and logging from the test, provided that it performs the actions that it has been created to perform. And in this case, we are performing two tests. We are performing the hello function, a test hello name, which passes a name value with which the function should be able to return a valid response message. If the call returns an error and an unexpected response message, one that does not include the name you passed in it, you use the T parameters error F message. So now we're going to come here and then we're going to say to print a message to the console. Let's see what the error F message means. So error F is equivalent to log F followed by fail. Okay, so remember when we used the what's it called, the log module, and we had something like this, right? So I think, but in log F we used a fatal, right? So okay, fail marks the function as having failed but continuous execution. Okay, noted. So it says that, okay, the function failed but proceed anyways, right? It's probably in a case where you have like subsequent test functions following that. But I want to know what log F is here. I want to know, did we miss this? Did by chance, did I miss this by chance? T dot, okay, so log F. Log F formats its arguments according to the format analogous to FMT printf, okay, and record the text in the error log. A final new line is added if not provided for tests. The text will be printed only if the test fails or the test.v flag is set. For benchmark, the text is always printed to avoid having performance depend on the value of the test v flag. It is an error to call log F after a test or benchmark returns. Okay, noted. So in this case here, it says that this is similar to the fmt.print f function in the fmt module, and what it does that is it records the text there, right? So it does not give us a new line if we ourselves don't provide it. But then in test cases, right, this will only be printed if the test itself fails, right? And if you're trying to do benchmarks, right, in this case we're not doing benchmarks, so this doesn't really apply to us, but it says that if you're trying to do benchmark, right, the test is always printed to avoid having performance depend on the value. So in that little benchmark test, right, normally you wouldn't want this to be printed, right? But in this case here, this is always going to be printed because and this will affect performance even if it's by a couple milliseconds, right? It all counts at the end of the day. But I understand what that means now. What I would love to understand better though is still what the QV and all this stuff are. I know over here it's when we came here it was the error F, I believe. Yeah, the error F. Let's see if we can check for that here, something like this. No, we can't check for that. Let's say, what does meaning go? Right? String formatting, right? So it's called string formatting. Okay, so Go offers excellent support for string formatting in the printf tradition, right? And I remember when we were looking at the testing here, when we were trying to get the context, it says that where's that? Log F, right? It's similar to the printf here, right? So I'm guessing since it's similar, this values used for string formatting are also going to be present here, right? So things like v, n, and so v, b, t, x, e, and all this stuff, right? So let's see what this means. If the value is a struct, the plus v variant will include the struct's field name. The hashtag v prints a Go syntax representation of the value. Or there's actually quite a lot that we need to study, right? We would have this study at another time, right? But for now, let us implement this into our project, right? So we're going to say package greet, and then just like it's here, we are going to import two things, testing and then the regular expression. So we're going to import testing, and then we're going to import reg exp, and then we're going to utilize this here. So we're going to say function test greet me, right? And we're going to pass in t, which is a pointer to testing, I believe. Do we say testing dot t, right? Is what's called here. And then we are not specifying the response, which is interesting. So we're just gonna return this, and then we're gonna create a name. I'm gonna say the name is the Aldorax, and then here we're gonna also return want, which let me add a comment here, right? So a want is pretty much what you are searching for in a response to make it qualify for a pass. So this is pretty specific to our context here, right? So do note that. I'm coming. Just let me make things easier. So yeah, this is how it works. And then we're gonna create a reg exp. So we're gonna say what we want. Well, not a want. The want variable here. Okay. So this is what we want, and then what we want here is a reg exp dot match string, right? So match string reports whether the string s contains any match of the regular expression pattern. More complicated query needs to use the compile. So we are pretty much passing in a pattern of type string, and then we are passing in the string itself, right? And then we are saying that, okay, do they match, right? So in this case here, what this means, but in this case here, we are not using quotes, right? So in this case, why would one need to use in Go? So they used okay. So backticks, not why they matter itself. It's what is the use of backticks in Go, right? So we are doing this for Go. Does anyone know whether you should use backticks every time you don't have a string that needs interpolation? There's no performance difference. So that would mean the only reason to use backticks are just personal preferences, or if you just want to use this. Double quote strings pass escapes like these back strings do not. They compile down to the same point where one is more convenient than the other in some circumstances. Like being able to specify numbers in decimal, does that have real value when we could just write them in binary? Okay. So there's no difference. So we can still take this as a string itself, and then we are doing -b. What does /b in Go mean? In Golang mean? How do I disable? I want to disable the AI here. It's starting to be a pain to me here, because what is this helping me with? Go operators. -b, I believe, or is this -b? No, we don't have this yet, right? So we would do a search for what that means at the end of the day, right? But it says must compile. We do a quote, right? And then we have /b here, and then we pass, we do a plus name, right? Then we do a plus, and then we do another slash b, right? Which is what it is. And then we pass in the message, and then we pass in the error, and then we want to do greet dot greet me, and then we want to say name, right? Or did I pass that wrongly? Okay, dot hello. Okay, so we are not gonna just do that. We're gonna say okay, we don't wanna do this. We already have this. We're in the same package, right? So we can just say greet me, and then we're gonna say, are we gonna pass in the name itself? We're gonna say the Audorax, right? And then we want to say if not interesting want dot match string message, and error is not new. Oh no, that's different. Error, yeah, error is not new. We want to then do a t error f, t dot error f, and then we want to pass in this expression again, and we're just going to say hello, and we're going to pass in the Audorax again here in this text, and then we're going to say is equals to, does this come after the quotes though? Okay, it doesn't come after the quotes. It's still present within the quotes. Is equal to, okay, now that I think about this might just be used as placeholders, right, for specific things, right? So we have Q, V, and then we have this for Q here, which is an interesting thing. Although this particular operand hashtag Q is an interesting stuff, right? But we have Q, we have V, and everything. In as much as I know that there might be specific meanings to this, we can notice something after the comma here. We have the same three operands that we don't understand what they mean, also the same three variables that are also being passed to this, right? So I'm also assuming that this will be arranged appropriately to the sequence as to which this is also present here, right? So this is going to be message, this is going to be error, and then this is going to be want, right? So we're gonna test that though. We're gonna see if that works. We're gonna do is this and or at? Okay, yeah. So this is Q, V, and then want match for and hashtag Q again, right? And then here, okay, we separate using commas, and then we say message, we say error, and then we say want. Okay, I believe that is accurate, and then here we close our function, right? So one variable, but this expects two variables, right? Okay, so okay, not match string. Okay, not match string. We made a mistake here. It must be must compile, right? And so must compile is a different case. What does must compile do? Must compile is like compile, but panics if the expression cannot be passed. It simplifies a safe initialization of global variables holding compiled regular expressions. So what does compile then mean, right? So it says here that compile passes a regular expression and returns, if successful, a regular expression objects, right, an array that can be used to match against text. When matching against text, the regex, the regular expression returns a match that begins as early as possible in the input leftmost, and among those it chooses the one that a backtracking search would have found first. This so-called leftmost first matching is the same semantics that Perl, Python, and other implementation use, although this package implements it without the expense of backtracking. For POSIX, leftmost longest matching, see compile POSIX. Okay, this is an interesting thing. So we want to do this, and I'm just gonna do go tests. Okay, we're gonna cd into greet, and then we're gonna run a go test. Okay, it says pass. Okay, greet, and so this actually worked. And then now we're going to implement the second one, which is test function test hello empty, which also takes in a parameter of t called t, which is of type testing, of type pointer to testing.t, right? And then that's what we use in this case. So we want to do message, and then we want to do error is equals to, I believe, hello, or rather greet me with an empty string. And then if message is not equals to empty string and error is equals to nil, I want to do something. We want to do t dot error f. What is wrong with this? Why does, oh, okay, I did this. It's meant to be this t dot error f, and then we're gonna just do what is the message we want to do? We want to do same thing, qv, but we're not doing once. Since we don't have once here, we're just gonna say hello, and then this is going to be empty string, I believe, right? Yeah, this is going to be empty string, and then we want to do q is equals to this q and then this v, and we want to say want this, and then we want to do message, and then we want to do error here. Okay, great. So in this code, implement the text function. So we did everything there. When name says something about a specific test, we did all that. Okay, so we want to do go test, right? And then we want to see if this is going to work. All the changes that we've done here, go test, and then this should work just fine. So this worked great. Let's test this again. Okay, so obviously the time for the testing, it only goes down, right, which is great. And then we also want to do a go test, but with like a verbose, right, which is great. So test greets me, pass, test hello empty, pass. Okay, this is great. I still did not see the whole stuff here, right? Okay, so because everything is passing, so we didn't get an error. So the test hello name test checks the return value for the name is specified as the hello function parameter to view. A failing test result change the greeting so that it no longer includes the name. In greetings, greeting.go, paste the following code in place of the whole hello function. Note that the highlighted line changes the value that the function returns, as if the name argument had been accidentally removed. Okay, so we have in here, we have the greet me, right, which we had in our previous code, but here instead of message is equals fmt dot okay, we are not passing in name, we're just passing in random format here, right? So that is the difference between this. So we are gonna just remove this here, and then we're gonna try and call the code here, and it says non-constant format string in call to fmt sprint f, right? Which I think we are doing something wrong. I don't think it should be fmt. Okay, it should be sprint, not sprint f, right? It should be sprint rather. Okay, my bad there. So then what's the difference between sprint and sprint f? With sprint uses the default format for its operand and returns the resulting string, and then with sprint f it returns according to to a specifier. Okay, I get this now. So we see welcome to the club. Neil wants match for the Audorax. Okay, so you have to be the Audorax in order for you to pass, right? So this is great. and then at the command we would see this error. So great, guys, we've actually built and we've integrated a test into our project, and now we're just going to finalize everything by compiling and then installing our application, right? So in this case it says go build, right? So in this case I'm just going to go back to my previous code here before the change, and then it says from the command in the hello, just run the go build, and it's gonna compile this into an executable, right? So I'm gonna clear this, and then I'm gonna say go build. Interesting. I think I ran the command in the wrong function, because this should be hello here, right? This should be it, right? So yeah, I think I ran that in the wrong place. I should have done this here instead. So go run build. Is it go run build or go sorry, I think it should just be go build. Just go build, right? So go build. Okay, so we did that, and then what we want to do is /hello. I don't think I'm seeing any. Oh, /learn. Okay, we have ours to ./learn, and it actually worked, guys, right? So we actually have an executable, right? We actually have an executable that we have. So we have this, but to run it correctly, your prompt needs either to be in the executable directory or this. Next, you install the executable so you can run it without specifying its path. So you can discover the install path by doing go by running go list command, as in the example here. For example, the command output might say this, meaning the binaries are installed to this. You need this install directory for the next step. Okay, so I'm just gonna do this. I'm gonna copy this in this case here. I'm gonna paste this, and then okay, we can see what this is. So I think what it does is that it says we want to find everything that has dots, right, and then it targets, right? So the targets here is going to be any file that comes after this dots, which I want to try here, right? Before we actually proceed, let me just do something like a go .nem, all right, and then I'm gonna run this. Or let me put this in the greets, and then I'm gonna do this. Interesting. I guess that does not work per se, but we'll figure it out. So add this. We're gonna say export path, and then we're gonna get the path here. So the path here is the one that we have here from this place here. So we're just gonna do this, and then we're gonna paste this here, and okay. Okay, so we're gonna do this, and then we're gonna say go install, and then since we have go install, we're just gonna type in our terminal learn. Interesting. So this didn't work. What did we do wrong here? So we exported the path, right? We exported the path, which is pretty much, I'm just gonna shrink this, right? So we exported the path to the directory, and then we did go install, but that did not work. Well, let's try go env win gobbin is equal to path, go install not a directory. When it says not a directory, what does it mean? This is an interesting thing. Um slash path to the bin. Do we need to specify? And then go install, and then what do I do? Go install learn, and then learn. It still did not work, right? Do I need to open a new terminal and then do learn? It still did not work. Interesting. I'm gonna pause this video and read the documentation a bit and see if I can find something out real quick. Okay, after a lot of investigation, I realized what was causing the issue and why this was not working. Right. So this was because for some reason the Z shell that I have was not having the path in it, right? And this was noticed when I investigated and I did the nano Z shell env file, which only had the flutter and the cargo here. It did not have the one to our build from Go, which is this, and that is why I just added it here, and I just saved it. And then now if I go to my terminal, right, and I type in learn, it works, right? It works automatically. So on my system here, we already have everything installed. So this is really great. I mean, we've covered how to build an application, how to install the application to your shell, and how to just have it present and be able to call it, right? We've learned a lot from this series. We've learned starting from how to write functions, what modules are, what packages are. We learned about the Go mod in it. We learned about Go mods and how to utilize a module, especially in a case where you're offline, how to sort of reference another package inside of another package. We learned about error handling. We learned how to deal with greetings and specifying strings, arrays, data sets. We learned about types to a good extent, not fully, but we learned about types. We learned about compiling an application. We learned about installing the application, writing tests, and much more. We've actually done a great lot. If you have gotten all the way to this point, congratulations to you. You now know something about Go. Now we would want to obviously further our understanding of this by going through the documentation step by step to understand even more in-depth information about all this, right? So we have a conclusion and links to more stuff. We can do this, which is called go. And yeah, so this is one of the best ways to learn Go. I actually got this from a friend who says that this is one of the best things because here you can actually write the code and test it. You can actually experiment and at the same time have the documentation on the side so that you get this seamless understanding and knowledge of how it works. So thank you so much for following this series. If this series has been helpful to you, do make sure to like it, subscribe if you want, if you feel like we are pushing out good videos, and if there's something specific that you really want to learn, right, then drop a comment in the comment section telling us how what exactly your problem is, and what you would like us to do a video of, and then if it works out, we would be dropping a video on that in future series, right? We're also going to be doing further series, right? An extended series of Go where we go into where we follow the tour and we pretty much go through every single section of this tour, understanding a lot of things here. We're going to not just be dealing with Go, but we're also going to be dealing with mathematical theories. We're going to be dealing with principles of coding. We're going to be dealing with a lot of data structures and a lot of things that you would say or you would know in order to become a fully fledged Go developer, right? We're also going to be looking at, working with your terminal, working with VS Code and any code editor, how to pretty much utilize path properly to make sure that you're not having errors in your code. We're going to deploy a module online, and then we're going to call this module and actually utilize this module in a production project, which will attach to, let's say, a Vercel link or an Amplify link or something, and we're just going to get that up and running. So it's going to be a really extended series with multiple videos present in that series. Some will be long, some will be short. Everything we will try our best, or rather I will try my best to make sure that they can be viewed independently, which means that you can go view a specific video and just learn about that video, and you don't need to like follow through with all the videos. But if you feel that you want to go through all the videos, please do make sure to subscribe so that the notifications are gonna hit you. And like I always say, if I have made any mistake in my study of Go here over the series, feel free to drop corrections in the comment section. I really appreciate you guys who have subscribed and liked the videos and have interacted so far. Thank you so much, and have a great day ahead. Bye.